Another very useful kind of functional kind of MRI technique that's been developed is something called resting state functional connectivity, MRI or RSFC MRI. And basically it's looking at tiny blood flow kind of fluctuations, in regions that are interconnected across the brain that form, networks that are engaged in specific sorts of tasks, like networks that are involved in sort of salience detection or attention, external attention, or default, with basically like kind of internally directed rumination, and planning, and memory and things like that. So as networks, as distributed regions of cortex become more effectively linked by long-range tracks, by white matter tracks, and more effectively sort of share information and coordinate their activity to engage in these tasks, to be able to carry out specific perceptual, cognitive, or behavioral sorts of functions. It was noted that if you just have people sitting in an MRI, let's say dorsolateral prefrontal cortex and posterior parietal, and the anterior cingulate maybe are, a coordinated network for, selective attention. Well, even if they're not attending, just in the resting state, you'll see, DLPFC, increased blood flow, PPC, increased blood flow, ACC, increased blood flow together. And then they'll drop, and then they'll go up, and then they'll go down. So there's like a coordination. There's like correlated fluctuations in blood flow, between regions that actually reveal functionally linked sort of cognitive networks. And this RSFC MRI has been very useful in sort of tracking changes in network development, like across adolescent, brain development, for example, and in disease states, for example. You can explore that utilizing this resting state functional connectivity MRI.